Hello, Algebra 1 students, and welcome back to your Semester 2 final review. We're on to problem 32, which comes from lesson 7.2 if you want to take a look back. I also did a pretty in-depth analysis of this type of problem in problem 31, just one video before this, but I'll try to do the same here so you don't have to flip back and forth. So, we want to translate, which means move, the graph of f of x equals x squared to the left 4 units, up 3 units, and vertically stretch the graph by a factor of 5. Which of the following is the function after the transformations? Well, let's start at the beginning. We are going to look at, and I'm just going to try to do this all on one xy plane. And as a reminder, on your final exam, they give you these blank graphs if you ever want to graph them, but you can always sketch one like I'm doing too. We're going to start with our original graph, the OG guy, f of x equals x squared. And we should recognize this actually as the parent function, where our parent function, right, is shifted left or right 0. We can always add in zeros to our x squared, and has an a value of 1. So our parent function, y equals x squared, just starts at 0, 0, and is going to go up 1 over 1. Okay, 1, 2, 3, 4, 5. I'll just try to go 5 in each direction. I think that's as far as we'll probably need. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Alright, and I may be wrong, so I may have to change things later, but that's okay. So my original graph, 0, 0, up 1 over 1, up 1 over 1. This is our parent function, our OG parabola. And what they want us to do is they want us to translate or move this parabola left 4 units, up 3 units, and then vertically stretch the graph. So let's start with the left and up. Left 4 units, 1, 2, 3, 4. So I have to go left 4, and then up 3, up 1, 2, 3. Notice I'm just doing this from the vertex. That's really kind of the origin point for my graph. And we should do this in a new color, I think. We'll do it in blue. So it starts right here. So this new vertex, if we're looking at it, is negative 1, 2, 3, 4, comma, up 1, 2, 3. Negative 4, comma 3 is our new vertex. But then we don't want to just go up 1 over 1, up 1 over 1, and sketch in a parabola, because they actually want us to change the steepness of our parabola. They're asking us to vertically stretch this graph. Now, when you vertically stretch a graph, you can think of this graph as someone reaching down and grabbing the edge of the graph and vertically, so up and down, stretching this super far up. And if you were to pull these endpoints up really far, this graph is going to get skinnier. So when you vertically stretch something, it gets skinnier. In this case, if they tell us they're vertically stretching by a factor of 5, what they really mean is they are multiplying the a value by 5. So instead of the a value being 1, my new a value, 5 times 1, will be 5. And so what we're going to do here is we are going to go up 5 over 1. So up 1, 2, 3, 4, 5. I've run out of room, but that's okay. Up 5 over 1, up 5 over 1 looks like this. And can we see that our parabola is definitely skinnier than the original, than the purple parabola? That's what vertically stretched graphs look like. They get skinnier. At this point, I think we have enough to write the equation for my blue parabola and then see which equation matches it. So, y equals, we know our new a value is 5, or 5 over 1, x squared, leaving some blanks for the h and the k, opposite of h, plus 4, k value, plus 3. Which equation matches that? Well, this one's 1/5. If we had put 1/5 in front, we'd have had to treat this as 1/5 over 1. And so to go up a fifth, that's very, very small. That's 0.2 as a decimal. I'd go up a fifth and then over 1, up a fifth over 1. This parabola would not be vertically stretched. We would say it would be vertically compressed. Compressed is like pressed down to the ground. It is wider. So vertically compressed is what our 1/5 would do. Anytime our a value drops below 1, like a fifth or a third or 2/3, it makes our parabola compressed or wider. However, our a value was greater than 1. It made it skinnier. That eliminates a and b right away. Looking at c and d, they're trying to trick you here. They want you to think that's negative 4, but that's positive 4. That would be right 4, up 3, and it's not our left 4. The only one our equation matches is c. Thanks for tuning in. Hopefully this was clear. If you guys need any extra help, as always, just let me know, and hopefully you keep finding success on your Semester 2 final review.